under the hydroxy compounds topic, we have taken so far alcohols, we have discussed it, phenols also discussed, and ethers also we have discussed. This is a small, that is the last fourth topic, that is glycols. In fact, the glycols are nothing but the two hydroxy functions side by side, that is vicinal. The vicinal means side by side. On the same carbon we call geminol. This is a vicinal diols, or 1,2 diols. Smallest example or the simplest example will be the ethane with the two OHs side by side. If the OHs are on the same carbon, in fact that is a unstable compound, because in the carbon chemistry it is very simple. Two OHs if it is there, one water molecule will go. Or take a carbonyl compound, add water, you will get the 1,1 diols, but they are proved to be unstable and give back the carbonyl compound. Therefore, there is no much study about the 1,1 diols. But 1,2 diols, the preparation as well as some of the specific properties are important with reference to the JEE and EAMCET also. So, therefore, let us see this how these diols are prepared, and as well as how these compounds slightly differ from the rest of the compounds. General preparations and general properties of alcohols we have already covered. Therefore, I will not go into the general properties of OH. Specific properties, whenever two OHs are side by side, they show some special reactions or the special properties that we will emphasize in this particular topic. So, this is the simple example, may be called systematically 2 carbon, therefore eth, single bond, therefore AN, 2 oles are there, so therefore it is diol. These 2 oles are 1 and 2, therefore it is called 1,2-ethane diol will be the systematic name. However, it is prepared from ethylene. The best method is from ethylene, adding the Bayer's reagent you get. Therefore, it is also known as ethylene glycol. Ethylene glycol. A glycol is a common name for 1,2 diol. So, glycol is formed from ethylene. So, one of the common method, that is addition nomenclature. From ethylene something by adding you got it, therefore, it is called glycol formed from ethylene. So, somebody extended that nomenclature, ethylene glycol it is. It is a common name. However, systematically 2 carbons, ethane single bond, so 2 oles diol, and the position we must mention, because the OH, 2 OHs can be 1,1 also, it is unstable, leave it. But whether it is 1,1 or 1,2 should be very clear. Therefore, this 1,2 is a must. 1,2-ethane diol is commonly known as ethylene glycol. So, with reference to this compound, we will see some preparations and the properties of this compound. So, let us see how this compound is prepared, or general preparations of these diols. Many methods are from alkenes. From alkenes we can readily convert. The first method can be, you take ethylene, add alkaline KMnO4. Alkaline KMnO4. This alkaline KMnO4 is also known as a Bayer's reagent. Bayer's reagent. Acidified permanganate is a little strong oxidizing. This is a basic medium. Permanganate in the KOH or potassium carbonate, you dissolve it, and that solution we are using as a Bayer's reagent. Actually, Bayer introduced a neutral, cold, dilute, aqueous solution, but anyhow the solution becomes later into alkaline. So, let us add alkaline only instead of taking all that care. So, alkaline solution is a mild oxidizing agent. So, MnO4 attacks on this compound, finally leaves a 2 OHs. Specifically, if we are interested that which side these OHs have come, means specifically from the 2 OHs from the same side. The reason also can be quoted like an alkene, the MnO4 attacks from one-sidedly it will attack like this. So, a complex is formed with KMnO4 attacking. So, the whole KMnO4 is a single digit. It cannot be half from this side, half from that side. So, one-sidedly added. Therefore, when you hydrolyze it, This compound leads to give this type of the 2 OHs from the same side. This type of attack either cis or syn addition. Syn addition means from same side the OHs are coming. Whereas another method we have, second method, same alkene you take, make into an epoxide by adding the silver oxide or peroxide, say, convert this into a epoxy compound, that is a cyclic ether type of the compound is formed. This on hydrolysis. Hydrolysis can be again in the acidic medium or in the basic medium, either one okay. So both will give the, in the acidic medium proton attacks and then the water comes from the lower side. So therefore you get a glycol wherein 2 OHs are opposite in direction. Okay. So this type of addition specifically, reason also we are giving why this type of the addition means the H plus attacks from one side, the water comes from the other side. So one side it is blocked, therefore the approach of water or the second OH come from the downside, which leaves a anti-type of the this one. So therefore this is called trans addition or anti-addition. So there is a small difference in the approach of the groups, but the product is same, starting material is same. Ethylene we have taken, we got a glycol with 2 OHs same side and a glycol with the opposite side. But both these methods on a specific compound, how this differs, let us take one beautiful example. Now let us see the application of these A and B methods on a given specific example. First example 1, you take ethylene and get the answer, A method and B method. What is that A method? A method is alkaline KMnO4 I said, B method is making epoxide followed by hydrolysis. So I will repeat, otherwise it is alkaline KMnO4. This is a first epoxide formation. Epoxide formation can be with different reagents. You can add silver oxide or the any peroxides or per acids like peracetic acid or and so on. So to add a oxygen on the double bond, you get a epoxide, then followed by hydrolysis. The hydrolysis also I said it can be acidic medium or basic medium. So you will get the 2. In these 2 cases, the answer will be like this. So 2 OHs are same side, so therefore let us write 2 OHs from the down side as we have seen in the last case. So 1 OH from the down, 1 OH from the top. Now if I say this is A, this is B, what is the relation between the A and B? Means A and B are nothing but the ethylene glycol only. Only thing is with reference to the double bond, 2 OHs same side, 2 OHs are opposite side. These are interconvertible in fact. And what is the relation means? The relation is they are conformers. They are conformational isomers, because with reference to the single bond 2 OHs need not to be in the same side, they rotate, single bond rotate, therefore the products formed are nothing but the conformers. Now let us go to the example 2. In the example 2, let us take an alkene like a cyclohexene, and wherein you apply now the same reagent A and B, what happens? In the first case, the 2 OHs will be on the same side, either on the up or on the down, lower side also. The second case, you will get the 2 OHs, 1 OH will be one up, 1 will be down. So now the relation between this product C and the product D. So what is the relation between C and D means? These two are not interconvertible. Once the 2 OHs are formed from same side, there is no interconvertibility. They are geometric isomers. They are geometric isomers now. They are not interconvertible. They can be converted into other by removing the OH and giving the OH from the other side. Unless you break the bond, you can't convert. So therefore, it is simply you can say that they are not convertible at ordinary conditions. So therefore, C and D are geometric isomers. One is a cis compound, the other one is a trans compound. You can also say they are cis-trans isomers. Now let us take another example, third example. If I take a malic acid means two COOHs are same side. This compound itself is one of the geometric isomers, cis isomer I have taken. Then you are applying the A and B. It is a cis compound, addition is also cis. So the product formed will be finally the two OHs will be on the same side and the two COH will be like this. This is called a mesotartaric acid. Mesotartaric acid, let us say this is isomer E is formed. Okay. Now in the case of the cis compound, the addition, if it is a trans type, compound cis trans addition will make the two OHs opposite in each other, and this isomer is totally different from the other isomer. You also get one more, a mixture of two compounds are formed. These two compounds are called, if one becomes dextro compound, the other one will be the D, both are tartaric acid. So you get a D-tartaric acid and L-tartaric acid, wherein two OHs are opposite, clearly it is mentioned. The addition is cis compound, addition if it is syn type or the cis type of addition, and this is the anti-type of the addition. So syn addition will give the on cis compound, OHs will be same side, mesotartaric acid is formed. And if the isomer, if I give E, F and the G, and these two are what is the relation between the E and F? E and F are called diastereomers. F and G both are formed in the second reaction are enantiomers, isn't it? A set of enantiomers comes in this case, whereas the addition, if it is cis, its diastereomer is coming. E and F are between these two, the relation is diastereomers. So it is totally stereochemistry controlled, the additions both are, but in the case of ethylene, the products formed are interconvertible or nothing but same, they are conformers. In the case of fixed alkenes, the cis and trans are giving different, where the rotation is not possible, therefore the compounds are not interconvertible, they are obviously geometric isomers you got. This is a rare case of addition, wherein the isomer itself is already fixed geometric isomer. You can take a trans compound now here, that is fumaric acid on trans addition, you will get mesocomp. Cis compound and cis, this is malic acid with cis addition, you will get meso. Fumaric acid and trans addition also you will get the meso. This is called stereospecific additions. So the reactions are very simple, but taken examples are different. So therefore, a respective complicated type of the answers can be discussed taking this type of the glycols formation. So now under the preparations, let us go for the third method. You can take an alkene, add HOCl, hypochlorous acid. So one side OH will come, the other side Cl will come. Hydrolysis in the basic medium, you will get the diol. So one OH, one Cl you can get it and then hydrolyze it, or you can have add chlorine, you will get dichloro compound, and hydrolysis of this nucleophilic substitution will give the diol. So all this 1, 2, 3, 4 are A, B, C, D. If you take these methods are nothing but the converting alkenes into their corresponding the glycols we can prepare. But we have some specific methods also, like taking the ketones. A special method can be that a ketone like acetone, if I take, this undergoes reduction with magnesium metal. in presence of dry solvents like xylene or ether, inert solvent if you take, then the magnesium will have two that is free electrons in the configuration S2 system. Out of that, one electron is given here, one electron is given here. From here, one electron will come, this electron will go to the junction, and here from electron will come, and this electron go to here. A bond is formed, and you will get a glycol formed, but magnesium will become into +2. A glycol salt is formed actually, not directly the glycol. Magnesium salt of the glycol, a new bond is formed because of the one electron from here, one electron from here makes a joining between the ketone carbon and the ketone carbon, a bond is formed. So the two ketones are joined, but however, it's a magnesium +2 salt is formed. The salt and hydrolysis or acidification, you will get the glycol, that is OH and the OH. So this specific glycol, you also can call it as a tetramethyl ethylene glycol, commonly known as penacol. We have a reaction that we'll discuss later. But in the preparation of this penacol, if you take acetone, two acetones are reduced to penacol. So therefore, the reaction specifically also called penacolic reduction. Or ketones are reduced, therefore it is also said ketonic reduction. With magnesium in dry solvent like xylene or ether, it gives this type of a new bond formation between the two carbonyl carbons, and O will become into O dot with one electron of magnesium will become. So magnesium is giving electrons and reducing the ketones into the alcohols. However, they join, so therefore two alcohols side by side comes, that is the glycol is formed. Ethylene glycol specifically with 4 methyls are there, therefore I call this one as a tetramethyl ethylene glycol. Commonly has a common name called penacol. Penacol is just a common name somebody has given, and it has become very popular. Penacol is nothing but a ethylene glycol with 4 methyl groups. So let us call tetramethyl ethylene glycol is known as penacol. So these are all the preparations for the glycols.